All right, I think we'll get started now. Yeah, just like that. All right, guys, we'll get started now, okay? And the other people can just join quietly when they get back. Do you need to move, or no? You're sitting there. Okay. Right. So last week we were looking at absolute modulus. Yeah. And this week we're going to have a look at compound and double angles, which is related to trigonometry. Now, I'm just going to present it to you as these are the formulas, okay? So we have 6 formulas, but really it's only, well, oh no, okay, it's more like 12 formulas, but really it's not as much as that. So the first formula I want to show you is how do you calculate sine of A plus B? Now, I'll tell you what it's not. It's not going to be what? Sine A plus sine B. Okay. That's wrong. Okay, we all at least know that, so that's good. So the formula for sine A plus B is, actually, yeah, who knows it? Is it sine A?
Cosine A.
No, sine A cos B plus sine B cos A. Now the good news is, if you need the formula for minus, all you do is you change this to a minus. Yeah, so that's 2 formulas in one. Okay, so if you can write that down, that's our first formula here. Hey, come on, focus now, focus. You got that? Amjad, come on, I need a bit of focus here. Have you got your pen and paper? Yeah, come on. Right, the next one, obviously we can see what's going to happen. It's going to be cos A plus B. Now, huh? No, it does.
No, we will start with cosine and it should be cosine, something like that. Has something.
It's definitely something like that for sure. Right, cos A plus B. Now, no. So be quiet now. Right, it's cos A cos B minus, this is where you could make a mistake. It's minus, not plus. Yeah, sine A sine B. And if you wanted cos A minus B, then it'd be cos A cos B plus sine A sine B. Okay. The last one, oh, well, there's still a few more. Tan A plus B is, it's a division. Yeah, it's tan A plus tan B over 1 minus tan A tan B. Okay, and again, if you change the sign, so if you were to write a minus here, this would become a minus and this would become, let me just put the minus underneath, that would become a minus and that would become a plus. Okay. Actually, I better double check that now. I'm not sure about the minus in the denominator, if it needs to be changed or just the numerator. I'll have a quick check here. Come on, Mubarak, a little faster. Now, what's wrong? Come on, guys, I need a little bit less talking now. Yeah, no, that's right. Yeah, that's it. Yeah, you need to change the signs for the top and the bottom. No, hang on. Okay. We have to, there's been too much talking now, so if people are continuing to have conversations from this point on, I'm just going to ask people to leave, okay? So I need a bit more focus now. Right, so we have these 3 formulas. We have 3 more to do, but the good news is the next 3 just come from the first 3. So these are called the compound angle formulas, and now we have the double angle formulas. Now the double angle formulas would be something like, for example, sine 2a. Now you can think about it like this. You can get the sine 2a from the compound angle formula, because you can think of sine 2a as sine a plus a. So then it becomes sine a cos a plus sine a cos a, and you realise, oh, that's just going to be 2 sine a cos a. Likewise, you can get a formula for cos 2a by thinking of cos 2a as cos a plus a. So that would be cos a minus sine a. So that would be cos squared a minus sine squared a. And finally, we have tan 2a equals tan a plus a, which is tan a plus tan a, so that's obviously 2 tan a, over 1 minus tan a tan a. So that's 1 minus tan squared a. So you have 1, 2, 3, 4, 5, 6 formulas here. You don't have these given to you in the exam. You will need to know them. Okay? So really what today's lesson will be about is what type of problems we could have that require these formulas. Some easy, some hard. We'll start with an easy one first. So please write these down carefully. They're called the compound angles and the double angles. Yeah.
We learned in this one that when you have sine 2 theta, we can divide by 2.
If you have what?
2a we can divide by 2.
Are you sure? Sine 2a? What do you mean?
When we had the double angles, we have...
Oh, is it? Three
Sine
bridge
2a has 3 formulas, right?
Means sine 2a, you can divide by 2a.
You divide the answer by 2.
Yeah.
No, that's different. That's when you're solving equations.
Yeah.
Now, but you're right though. You can actually use those formulas for those problems we did in semester 1. But it's only going to be useful for the problems where you have sine 2a. But if it was a sine 3a, well, not quite as easy to use. Anyways, let's have a look at some examples using these formulas, okay? Right, scrolling down. Oh, well, you all have this, yeah? Yeah, scrolling down, okay. So one type of question that you might be asked to do is to calculate sine 15 degrees, something like that. So the way to do this is with a triangle, and you're allowed to use the, okay, let me put it like this. There are 2 triangles you are expected to know off by heart. This triangle, which is 1, 1 and root 2, and that's a 45. You're also expected to know this triangle, which is 1, 2, root 3. And this is 60, and this is 30. Okay, so you are expected to know these triangles and to use them with sine 15.
Why sine 15?
Oh, this is my example, sine 15. So my question is, what is sine 15? Now, of course, if you have your calculator in the exam, that's fine. And if they let you use the calculator, which they should, that's fine too. But I'm just doing this as an example to illustrate the rule. So, yeah, you need to say sine 15, you need to think of it as sine 45 minus 30. Because you have 45 and 30 in these 2 triangles. So sine A minus B is sine A cos B minus sine B cos A. Sine 45 is 1 over root 2. Cos 30 is root 3 over 2. No. Open. It's good. Sine 30 is 1 over 2. Cos 45 is 1 over root 2. And you can see those from these triangles. So the answer would be root 3 minus 1 over 2 root 2. You can multiply above and below by root 2 if you like. But it depends on how they write the answer in the MCQ. They could leave the answer just like this in the MCQ. Yeah. All right, so it's a little example to get started. Let's look at a harder one now. Yeah, it is, but it's the first example. Okay. Can I scroll down? Next example? Yeah. So the next one now, I tell you. Did you have it? No, well then just say something. I'm powerful, but not so powerful I can read your minds. Because I have a funny feeling I would be horrified with what I see. Right? I think so. Yeah? Yes? Horrified.
Sorry.
If I discover what you really think of me, I'd be horrified. Right. Have you got that now? Okay. Next example. So this one here, I tell you that tan A equals 3 over 4. And we'll say tan B equals 55 over 48. And I ask you for something like cos A minus B. And all the angles are acute. Which means all the angles are less than 90. Okay. So if you want cos A minus B, you can use your formula, which is cos A cos B plus sine A sine B. Alright, but that's a little bit of a problem because we don't have cos A, we don't have cos B, we don't have sine A, we don't have sine B. We only have tan A and tan B. So, what could we do? Not quite sine over cos. So what we could do, yeah? Yeah, you need to draw the triangles basically, where this is 3 and this is 4, so this is obviously 5. And this one here, this one would be 55, 48, and could someone use their calculator with Pythagoras? No, impossible, it has to be more than 55, so I would say 62. 73. Okay, so now we can use the formula. Cos A, this is B. Cos A is 4 over 5. Cos B is 48 over 73. Sine A, 3 over 5. And sine B, 55 over 73. Yes. Wait, do you have a good reason for being late? I see a frappuccino in your hand. You were in class for the last 15 minutes? No, you weren't here for the last 15 minutes. Did you just like sneak out a minute ago to get a frappuccino? Really? Well, that's also not good. Okay. Right, I won't bother typing this in on the calculator. Were you really here and you just left like 2 minutes ago to get a frappuccino? Is that yes? Take the frappuccino. That's a good idea. I am feeling a bit warm here. All right. Next example now. I won't bother typing that in. Just type it in on the calculator, okay? Right. Let's look at one that's now a little bit harder. Oh, and I should say, of course, you have to be careful if it's acute or obtuse or so on, because there could be a plus-minus issue here. Like, for example, you've all seen this circle. Yeah, I'll explain now in the next example the importance of if it's acute or obtuse or so on. Just to be clear, acute is 0 to 90. Obtuse, 90 to 180, isn't it? And reflex is more than 180, isn't it? Or is it more than 270? Obtuse is up to 270 or up to 180?
180 or 180.
Both.
It depends on how you look at it.
Oh, well, I'll tell you now. No, so for me, yeah, I'm taking reflex to mean more than 180 and less than 360. Yeah. And obtuse is more than 90, less than 180. Yeah. Okay.
Right triangles.
Huh? I can write this down, yeah. Guys, just to be clear, if your angle is less than 90, that's acute. But more than 90, yeah, obtuse. And then more than 180, reflex then. And here what we're saying, ASTC, is in the first quadrant all positive, sine, cos, tan. In the second quadrant only sine, only tan, and only cos. Positive then. Okay, so let's have a look at an example here. I tell you that sine A is 3 over 5 and cos B is 5 over 13. And I also tell you firstly that A and B are both acute. That's situation 1. And in each question I'm asking you for cos A plus B. Okay, so cos A plus B, that would be cos A, cos B, minus sine A, sine B. Okay, now we have to draw our triangles again, don't we? So if I draw two little triangles here for A and B, this one would be 3, 4, 5, and the other one would be 5, 12, 13 from Pythagoras. Right, what's cos A? 4 over 5. Cos B? 12 over 13. Sine A? 3 over 5. Oh, am I wrong? Cos B is 5 over 13, sorry. Oh, so I drew this triangle wrong way around, didn't I? That's 5 and that one is 12 then, thank you. Minus sine A, which is 3 over 5, and sine B, which is 12, that's a 12. 12 over 13. 12 over 13, yeah. Is that okay? No, something's wrong with cos B. 5 over 13. Yeah, because it says it right there too. Cos B, 5 over 13. Okay. And again, you can just put that in on the calculator and you've got it. Right, now the next situation, part 2. If A is acute and B is reflex. So all the information is the same except I tell you A is acute and B is reflex. Right, so cos A plus B. We need to think about the circle before we begin. So ASTC. Now A is acute, so that means sine A and cos A and tan A, they're all positive. However, B is reflex. So which quadrant could I be in? Third or fourth. Now you can because reflex means more than 180. But you can actually figure out which quadrant I'm in. Is it the third or is it the fourth? Does anyone know? No.
All's change.
Which third or fourth? It's fourth. It must be the fourth because you know that cos B is positive 5 over 13. So you have to be in the fourth quadrant, which makes cos B positive, but only cos B positive, and then it would make sine B and tan B, they would both be negative. So cos A is positive. Cos B is what? Positive. Sine A is positive, and sine B is negative. So you see the only difference in this situation is that becomes a minus. That's right. Because it's 3 over 5, and 3 over 5 is positive. Okay. Situation 3, as an example. A is obtuse and B is acute. Right. Let's think about which quadrant A is in. So if A is obtuse, it must be really second one here, isn't it? And in the second quadrant, sine is positive, which it is. So this is where the A is. Now where is the B? B is acute, so it has to be here. So that means sine A, cos A, tan A, sine B, cos B, tan B. Let's figure out if they're positive or negative. Sine A, now hang on, here's A and here's B. Sine A, positive. Cos A, negative. Tan A, negative. Positive, positive, positive. So, if we use our formula again, it's going to be cos A. Cos A is negative. Cos B, cos B is positive. Sine A, positive. And finally, sine B, positive. And that's the answer. We get the idea? Yeah? Okay, so I think we've got a handle on the compound angle formula. Don't worry, in the exam they usually make it acute. Both angles are acute. But just in case they're not, be careful of the sign. Okay. And like I said, if you have your calculator, which you should, it's easy. It's much easier if you have your calculator. Let's have a look at double angle questions now. Can I scroll down? Yeah? Scrolling down? Yeah, okay, next one. So again, I'll keep everything acute to keep it simple. We have tan A equals 5 over 12, and I want cos 2A. Okay, so if we use our double angle formula, we can see that cos 2A would be cos squared A minus sine squared A. Well, we need to figure out cos and sine A. How do we do that? Again, triangle. This is 5, this is 12, and so this is 13. What's cos A?
5 over 13.
No, it is not.
12 over 13. Yes.
And sine A?
5 over 13.
And then we calculate it, and that's the answer then. That is okay, isn't it? Right. Next now. Can I scroll down? Okay. Okay? Yeah? So, we have slightly different now. Sine 2A is 24 over 25, and this time I want sine A. No, can't divide by 2. So, here we can change this using the double angle formula. This is 2 sine A cos A equals 24 over 25. Now we want sine A, and here is the problem. Not only do we have sine A, we have sine A cos A, and we're not going to be able to isolate sine A or the cos A.
Can we say sine A plus A? And then put it...
Yeah, but that gives us the same result here. Trust me.
Oh.
Yeah, so that won't help us here. Now the problem is we have sine A and cos A. We don't really want sine A and cos A, we just want sine A. So we need to get rid of the cos A. So the easiest thing, yeah?
We can put it 1 over sine.
No,
Sine over. Sorry?
no. Does anyone see how to get rid of the cos A? Must be quadrant 1.
Square.
Square. Before I square, I'll divide by 2, okay? Sine A cos A equals 12 over 25. Now I'll square everything. Sine squared A, cos squared A is 144 over 625.
Sir, when you divide it by 2,
Yeah.
how does it come 12? Should
24 divided by 2?
you divide by the whole thing, so 2 goes up, so it's 2 times 24, isn't it?
It certainly is not. It's not. Trust me. Divide by 2 and divide by 2. Yes. Okay.
And then 1 minus sine.
That's it. Yeah. Then cos squared can be changed into 1 minus sine squared A. That's equal to 144 over 625. Now, I'll have to cross multiply. 625 sine squared A times 1 minus sine squared A equals 144. Yeah? Next, I should expand. 625 sine squared A minus 625 sine power 4A equals 144. Now, I should take everything to the right. 625 sine power 4A minus 625 sine squared A plus 144 equals 0. It's a quadratic. So,
Place them by you. Yeah.
yeah, well, I'm not going to try and factorize this. I need a Casio 991. Pass that Casio 991 up. Are you? Casio. Okay. Okay. So, you can factorize this with the help of your calculator.
1625.
Yeah, it's going to be 25. What do I write here? Sine squared minus 16. 25 sine squared A
I think minus 9.
minus 9. Yeah. Now this means we have 4 answers to look at. You have sine squared A equals 16 over 25, or sine squared A equals 9 over 25. This means that sine A could equal 4 over 5, minus 4 over 5, 3 over 5, or minus 3 over 5. Now, 2 of these answers I can delete straight away. Why?
Negative.
Negative why?
Because quadrant
Because they're acute, which means they all should be positive. So straight away I can delete this one and I can delete this one. So the question is, which angle do I choose here?
you have to find check it.
Yeah, you have to check it. The first angle of 4 over 5 is roughly 53 degrees. And the second angle of 3 over 5 is roughly 37 degrees. Which one is right and which one is wrong? This angle here is roughly 50 something and this one's roughly 30 something. Which is right and which is wrong? No. This one here is wrong and this one here is right, because at the very start I told you all angles are acute, including the angle 2A. If you were to choose the angle 40 something, would that be too big? Or 50 something? That'd be too big. That'd be like 108. If you were to choose the angle here, which is like 30 something, then 2A would be 60 something, which would be okay. So the answer here is 3 over 5. Now I know that's a very, very hard one, but that is the hardest type. They don't get harder than that. And I would really, really be shocked if you got this in the exam, because I think it's too hard for the exam. Too hard. Okay, we're doing good. Okay, can you write that one down, please? We'll have a look at another one now. Guys, did you write this down? Did you write this down? No, that one out there. Do you see the one on the side of the bus? That question that's going by right now. I want you to write that one down. Yes, this one. I would be worried if I could read your minds. You guys should be worried if you could read my mind. Yes. Do you have this written down now? Yes? Okay. Do you have this written down? Can we do another example? Yes? What one did I give you? Sine 2a. Right. Let me give you one which I think is a little bit easier than this, and in my mind I could imagine it being on the exam. I think this one is a little bit too hard for an MCQ exam. It takes too long. But the example now I'll do with you I think will be the right level of difficulty. Again, all the angles are acute. All angles are acute. And we'll say tan 2a is 3 over 4. And I want to know what tan A is. This one is not so bad. We can use our formula for tan 2A, which is 2 tan A over 1 minus tan squared A. And that should equal 3 over 4. And you realise what's going to happen here, because you're trying to solve for tan A. That's nice, because you already have tan A on the left. So we cross multiply. We get 8 tan A equals 3 minus 3 tan squared A. Take everything to the left. 3 tan squared A plus 8 tan A minus 3 equals 0. It's quadratic. Is it quadratic with factors? Yeah. It's 3 tan A minus 1 and tan A plus 3 equals 0. So here we get tan A is a third or minus 3. Now which is it?
One of the three.
Yeah, because it's acute. It has to be positive. So this is the answer here. You see, so this one would be the right level of difficulty for the exam. Because all that you're being tested on is two things. That you know this formula, and that you know in quadrant 1 everything should be positive. That one's fine. Yeah. The last one here. Can I scroll down? Can I scroll down?
Yeah.
Yes. The last one is they might ask you for something like find a formula for sine 4a. Now that's not so bad, because the way you can think about it is you can think about it as sine 2a. So it's a double angle. It's double 2a. So the formula then would be 2 sine 2a cos 2a, because you can think about it like this. This is like sine 2b, where b is that. So that's 2 sine b cos b, like that. I'll write it out a bit clearer. So you can think of this as sine 2 by 2a, which is like sine 2 by b, if you call b 2a. So that's equal to 2 sine b cos b. But we said b is 2a. Yeah? Now we have a formula for sine with sine 2a. It's 2 sine a cos a. And we have a formula for cos 2a. It's cos squared a minus sine squared a. So we'll need to multiply this out. It will be 4 sine a cos cubed a minus 4 sine cubed a cos a, if you multiply that out. So look, these two multiplying this, cos squared by cos makes the cube. These two multiplying this, sine squared by the sine makes the cube there. And the reason for the 4? 2 by the 2 there. And I put the 4 on both because it's like 4 is on the outside and then I multiplied it in. So this is a question I could expect on the exam. You know, they could say something like sine 4a simplifies to, and they could give you this choice, and then they could make up 3 other choices. So I'm just going to make up a couple of fake choices here, like it could be a, this. Oh, of course, there has to be 4 sine a. Somebody's going to think that's the answer. I don't know. We could say something like sine squared a plus cos a, make up something silly like that, C, and the fourth answer could be, let's say, cos cubed a. Oh, it could be this, but maybe they got the sign wrong, you know, 4 sine a cos cubed a plus 4 sine cubed a cos a. That could be the fourth one. Whatever, it doesn't matter. 4 choices, okay? 5 choices, doesn't matter. Now, because you have your calculator, there is an easier way to do this, only if it's an MCQ, which it is an MCQ. So using your calculator, how could we figure out which of the 4 answers is right? If we didn't want to try and figure it out by simplifying, how could we use the calculator here as a shortcut to picking the right answer? Substitute, yeah. You could pick a value for A, let's say 10 degrees. You could calculate sine 40. So what's sine 40? Roughly 0.64, whatever. Then what you could do is you could take each of the 4 answers and sub in A is 10 degrees. One of them should match. In the situation that 2 of them matches, then choose a different angle to decide between the 2, like 20 degrees. If you keep getting 2 that are the same and you can't figure out which is different, it means they made a mistake and 2 of the answers actually are the same as the question. It's unlikely to happen. So if you pick a value like 10 degrees and sub it into your 4 MCQ answers, you can figure out which one matches. After all, it's an MCQ, they don't care about the work, you just need to match the answer up.
So how can you make the sine cubed here? Like that? Is it like this?
No. To make a cube, you have the brackets first and put the cos inside it. Like this. Brackets first, then cubed it, and then put the cos in it, or whatever, like that. Yeah?
Sorry, Stephen.
Yeah.
Is cos square A or cos square theta the same thing as cos A squared?
No.
Like
No. Be careful with the squares, okay? So just not to cause any confusion here. If you write cos squared A, that is not the same as cos A squared.
Don't mean in bracket.
Yeah, no, but you're right. It is the same as cos A in brackets squared. Yeah. Okay. Let me give you out. You could try these for a couple of minutes. Okay. sure. When you left, was I here when you left? I'm not sure your storage check is out. He goes on to absent. I'm not trusting your story. Because either you weren't here for 15 minutes or you were here for some of the time and then as I was teaching you left to get a frappuccino. Those are both bad things, right? Okay, fine. The second one is true. I'll have to think about what to do because nobody has ever got up and left my class for a frappuccino. So I need to think about this. What?
The problem with the frappuccino.
No, that's actually it's a frappuccino of all things.
Yeah.
All right, can you try these for a couple of minutes, please? Oh, sorry, you need your lid. Sit! Hey, come on, sit. Mubarak, come on, try these for a couple of minutes.